All right, so we're back here for part 2 here, or for the second video. We're actually in part 3, which is evaluate functions. When you see this word evaluate, what that means is to get a value. We're going to come up with a number, a numerical value for this. So number 3 says evaluate each expression using the following functions. Now there's 2 functions here. The first one is called f. Now you'll see f parentheses x, that is not multiplication. We read that as f of x. That's actually the same thing as y equals. So if we write f of x, that's called function notation. If I write it as y equals 3x plus 2, that's the equation. But they both mean the same thing. Equation, function. So this is the function, the set of x's where we substitute a number for x, 3x plus 2 gives us the y values. So the idea is that if we put a number into the function for x, what comes out is a y value. So there's the f function. There's a second function here, and we give that a different letter. We call that g in this case, g of x. But again, that means y equals, and it's negative x squared plus 1. So f of x, for every domain value x, the y value, the function value, is where we take 3 times x and we add 2. So if we want to evaluate f of negative 5, what they're telling us is to take that x value, the function is 3x plus 2, we're going to substitute that value for x, and then we're going to work it out. So that would be negative 15 plus 2, and we get negative 13. Okay, so f of negative 5 is equal to negative 13. Now again, this is not multiplication. It's not f times negative 5. It's f of negative 5. Where negative 5 is our domain value, and we substitute it for x, and then we work it out. G of 4, we go to the g function. Now that's the opposite of x squared plus 1. But instead of x, we're going to substitute the number 4. Now I do need to be careful here because when I do the order of operations, I am going to square the 4 first, which is 16, and then I take the opposite of that. So I'm not squaring the negative, I'm just squaring this number. And then negative 16 plus 4 is negative 15. When you're evaluating functions, what you're doing is you're taking an x, you're going into the function, and what comes out is the y value. So if x is 4, the y value is negative 15. If x is negative 5, the y value is negative 13. Now, if we have in part C and part D, notice we have both functions. We have f and g. This is called a composition of functions. We'll get into this later on in the school year. But what we do is we're going to work from the inside out. We'll start with g of 2. Okay, so what this is, it's a set of directions. They're saying use the g function, which is the opposite of x squared plus 1. I like to set up a parenthesis wherever I see my variable. And instead of that x, though, they give us a specific domain value, in this case 2. So this would be the opposite of 4 plus 1, which is negative 3. Now that's the value of g of 2. So I'm going to rewrite this now. So we have f of, we know that g of 2 is negative 3. So now my directions say go to the f function, which is 3 times x plus 2. But instead of x, we're going to substitute negative 3, and we get minus 9 plus 2, which is negative 7. All right, go ahead, pause the video here. See if you can get part D. Okay, so hopefully you've done this and gotten an answer. Notice that this looks almost identical. The only thing that's different is that the order of the functions has changed. From the inside out, we're going to start with f first. So we're going to take the f function, which was 3 times x plus 2, but the x value, the domain, is 2. So that would be 6 plus 2, which is 8. All right, now I'm going to rewrite this. So we have g, and instead of f of 2, I can substitute the value 8. That was the range value. Now we're going to go to the g function, which was the opposite of x squared plus 1. The domain, the x value is 8. And now we work that out. That's the opposite of 64. 8 times 8 plus 1. And we get negative 63. So we're just doing a lot of computation here. When you see this function notation, it can be a little confusing at first, but remember, what's the concept of a function? You take an x value, you plug it in, and what comes out is the y value. Take an x value, a domain, substitute it, and what comes out is the range or the y. Okay, so we can do this algebraically. Sometimes, though, they'll give us a picture. So number 4, evaluate each expression using the graph of f of x. Well, here's f of x, and we see we've got this shape here. So this is what the function looks like. Now you'll notice that if I take a vertical line, if I do the vertical line test, each vertical line would only go through one place. So this is a function. And so let's answer the questions here. Part A, we want to evaluate f of 2 equals question mark. So we have the x. They tell us the x. They're asking us for the y value. Well, let's use our knowledge of plotting points. If I take 2 on the x-axis, if I look up and down, notice that there's one place on this function f that has an x value of 2. Where's the y value? It's minus 2. That's it. All I'm doing is I'm looking for the ordered pairs that have these values. F of negative 2, when x is negative 2, what's the y value? Well, here's x equals negative 2. The y value is down here. It's negative 3. Now let's say the question mark is the x. So now they say the y value is negative 4. What's the x value that makes the y value of the function negative 4? Well, take a look at the y-axis, find negative 4. Now if I look left and right, oh, here's a point. What's the x value where the y value would be negative 4? Now that looks close to 4. I'm going to approximate here. It's not perfect. All right, go ahead and see if you can do parts D, E, F, and G. All right, so hit pause and do those, and then we'll see if we agree. All right, for part D, f of negative 4. So now x is negative 4. What's the y value? So I take the x-axis. Here's negative 4. Now this case, I go up to find the point on that function. The y value is 2. Part E, f of question mark, is 2. So when's the y value positive 2? So negative 4. So E is just the reverse of D. F of 0, when x is 0, what's the y value? When x is 0, we're on the y-axis, that's negative 2. And then f of question mark is 0. So when is the y value 0? Now that would be here. Here's the point. And it looks like it's to the left of negative 3 just a little bit, so I'm going to say negative 3.2. Okay, so again, the concept, we can do this algebraically by taking x values and substituting to find the y. But we can also look at it from a graph. Now, one other thing that I'll do here, I'm going to come back to number 3, and I'm going to take this function, f of x is 3x plus 2. What if I told you that the function value was 17? Okay, so what if I told you the y value, the outcome was 17, we wanted to find the x value that gave us that? Well, the question is, when is this function equal to 17? We can set up an equation here, and then we would solve. And divide by 3, x is 5. Okay, so again, we can work backwards. We need to understand the concept of a function because they can ask you questions in different ways. Okay, you can work from the domain to the range, but we can also work from range back to domain. We can do it algebraically. We can also do it visually. And that's the end of part 2.